Okay, for geometry today, we're doing section 6.4, rectangles, rhombi, right? Rhombus plural, and squares. So our objective is to verify and apply the properties of rectangles, rhombi, and squares, and then determine whether a quadrilateral is a rectangle, a rhombus, or a square. So we have lots of theorems. So instead of splitting these all up, I just put them all on the front for us to look at. Okay, I think there's 8 here. Okay, so the diagonals of a rectangle are congruent. So diagonals of a rectangle are congruent. That's one thing. Each diagonal, okay, of a rhombus bisects two opposite angles. So the diagonal of a rhombus is going to bisect the two opposite angles. So all the angles will be bisected. Diagonals of a rhombus are perpendicular. Remember, the diagonals of a rectangle are congruent. If it's a rhombus, they're perpendicular. Then we get into some if-then statements, okay, which are kind of cool. Okay, so if the diagonals of a parallelogram, are congruent, it is what? It's a rectangle. This one links right back to this one, right? So if we have a rectangle, we can say, hey, the diagonals of a rectangle are congruent. If we can prove that they're congruent, the diagonals are congruent, then we can say, hey, this is a rectangle. Okay, so we've got some, getting into these if-then statements is a little more exciting. The next one, if the diagonals of a parallelogram are perpendicular, then it's a rhombus. That's this one, right? Oh, sorry. That was the wrong one. I drew my arrow to. That directly relates to the third one we had, right? The diagonals of a rhombus are perpendicular. Well, if we can prove the diagonals are perpendicular, we can say that the shape, the parallelogram, is a rhombus. Okay, next up. If one diagonal of a parallelogram bisects a pair of opposite angles, it's a rhombus. That goes back to the second one, right? So in one, we're saying, hey, it's a rhombus, so the diagonals bisect the opposite angles. In this one, the if statement, if we can prove that the diagonal bisects a pair of opposite angles, then we can say it's a rhombus. So those are kind of cool how they go together. All right, moving on to number 7. If two consecutive sides, okay, so we have two consecutive sides of a parallelogram are congruent, okay, it is a rhombus. If two consecutive sides of a parallelogram are congruent. Okay, now make sure we realize this is two consecutive sides of a parallelogram. If it was of a quadrilateral, kite would be problematic, right? But this says two consecutive sides of a parallelogram. Then it is a rhombus. And the last one, let me move up. I was going to say scroll. I can't exactly scroll. The last one here says two parallel lines are everywhere equidistant. All right, so that means anywhere on here, like, so line M and line N are parallel. Okay, so if M is parallel to N, then for any 2 points, A and B, AD is equal to BC. So if we know, so if we put another point in here, okay, so let's say this was J. If we drew a line from J down here to K, that line is going to be equal to AD and BC. So that's also going to be equal to the measure of JK. Okay. If we put points on there anywhere, they're equidistant. Doesn't matter where. Okay, so there's all 8 of our theorems for the section today. Whew, that's a lot. So let's actually apply them a little bit. All right, so example 1 says find MN in a rectangle JKLM if JL is 5x plus 2 and Km equals 7x minus 6. Okay, so find Mn if JL, so that diagonal. Okay, so what do we know about, so they gave us JL and they gave us Km. So they gave us the measures of the diagonals, and we know that it's a rectangle. So what did we learn on the front side about the diagonals of a rectangle? Right, flip over. I have a second sheet here. Okay, it's that first one, 6.4.1. The diagonals of a rectangle are congruent. Well, if that's the case, okay, so we've got JL is congruent to Km. So we can say, well, 5x plus 2 has to equal 7x minus 6. Okay, so we can solve for x. I'm going to subtract 2 from both sides. So then we have 5x equals 7x minus 8. Subtract 7x. So I'm going to have negative 2x equals negative 8. Divide by negative 2. So we get x equals 4. Okay, that's helpful. We have x, but we have to find Mn. Okay, so we want from M to N, this segment right here, what does it measure? Okay, well, it might help if we knew Km first, right? We found that x is 4, but let's actually find Km. So let's take that 7x minus 6. Let's plug the 4 in. So 7 times 4 minus 6. So this equals Km. All right, 7 times 4 is 28. Minus 6 is 22. All right, so 22 equals Km. Again, helpful, but not what we need for Mn. What else do we know about those diagonals? Okay, hopefully you remember that the diagonals, this was from the day before, the diagonals of a parallelogram bisect each other. So that means this side, Mn, is congruent to Nk, which means that Mn should equal half of the Km. So Mn equals half of 22. So Mn equals 11. That would be our final answer, right? Find Mn. All right. Those are very Christmassy colors we've got going on there. Let's look at example 2 then. Find the measure of each angle in rhombus ABCD. Okay, I'm going to move this down a little bit. So find the measure of each angle in rhombus ABCD. So we've got angle 1 here, angle 2, angle 3, angle 4, and this angle, DCA, is 34 degrees. All right, so 1, let's look at what we know. We know it's a rhombus, okay, which is a parallelogram where all the sides are congruent, and they've marked that. Then we think about, well, what theorems did we just talk about that had a rhombus in them? Okay, so I'm going to go back to that for a minute. So that was the second theorem. Each diagonal of a rhombus bisects two opposite angles. Ooh, so the diagonals bisect the opposite angles. We also know the diagonals of a rhombus are perpendicular. All right, so let's look at that first one. Okay, so it says, again, this is 6.4.2. Each diagonal bisects two opposite angles. So this angle C right here has been bisected by this diagonal. So if this angle is 34 degrees, what do you think the measure of angle 2 should be? Yeah, it should also be 34 degrees, right? That's what bisect means, is those two angles are congruent. Okay, and so maybe we should make a note like diagonal of rhombus bisects opposite angles. I'll have to make my shorthand a little shorter, just so we remember like where we got that from. Okay, angle 1, the measure of angle 1, that was A. I kind of skipped ahead. All right, so the measure of angle 1 is here, and that goes back to that third theorem, 6.4.3. Diagonals of a rhombus are perpendicular. Well, if these diagonals are perpendicular, I put the perpendicular symbol, that means the measure of the angle is, excellent, it's 90 degrees. All right, so again, maybe we put diagonals of rhombus are perpendicular. Okay, we're kind of doing a little proof here with this. All right, C says the measure of angle BAD. All right, so BAD, so that's this whole angle here. What's that measure of that angle? Okay, well, these angles are opposite, right, of the angles over, it's angle opposite of angle BCD. And we know the angle measure of angle 2. This one's 34. The opposite angles have to be congruent. So let me write that down. So opposite angles of rhombus are congruent. So this is going to be 34 plus 34, which is 68 degrees. Probably shouldn't have circled that. I'll take up some extra space there. But yeah, so it's 68 degrees. Okay, how about angle 3? Angle 3. Let me erase because angle 3 is right in here. Angle 3. All right, good. It's 34 degrees. Good, right? Because it's being bisected. We know that angle BAD is 68 and the diagonal is bisecting. Okay, so diagonal of rhombus bisects opposite angles again. How about the measure of angle ABC? So here we go, ABC. So not angle 4, but ABC. What's that measure in there? What are you thinking? What do you know about the angles in a parallelogram? We talked about this yesterday. Okay, so hopefully you're thinking, oh, I know consecutive angles are supplementary. So if we know angle 3 is 68, not angle 3, sorry, angle BAD down here is 68 degrees, we need to take 180 minus 68 to get 112 degrees. Okay, because those would be supplementary. They have to add to be 180. All right, and then what about the measure of angle 4? The measure of angle 4. Okay, it goes back to that diagonal of the rhombus, right? So the diagonal of the rhombus, that's an H, bisects opposite angles. So if angle ABC is 112, this is going to be half of angle ABC. So it's half of 112 degrees, which is, good, 56 degrees. All right, so using these, we're using these theorems to do some work. You're also going to have to do some proofs, try some proofs in your homework. But we've got to show how it's being done. And there are some things. There's an example 3 and an example 4, but they weren't going to be helpful for me to give this way. So you can look back at them, but it's more of a, one's like using a carpenter, describe a way a carpenter can check the window is framed, and a paragraph proof. But we might go over those later. Then let's look at this last little note down here. Maybe not a little note, but this goes back to example 4, which is a great one. Like I said, you can go back and flip over to it and look at it. It's a paragraph proof, and that's okay. But we know because a square is both a rectangle and a rhombus. Okay, so we're talking about a square. Its diagonals bisect each other. A square. A square's diagonals bisect opposite angles. Its diagonals, a square's diagonals are perpendicular, and a square's diagonals are congruent. There is a lot happening in a square because it has both the properties of a rectangle and a rhombus. So all of those things we know about its segment, its diagonal length. We know about what the diagonal does to the angles. We know that it's perpendicular. We know lots of things. So to prove a parallelogram is a square, prove it is both. In order to do this, so in order to prove a parallelogram is a square, okay, you must prove it is both a rectangle and a rhombus. And if you flip to page 272 and look at example 4, you can read that paragraph proof. Okay, but in order to prove it's a square, you have to prove it's a rectangle and that it's a rhombus. Okay, that it's both of them. All right, good luck on your homework. You have lots of time. Please work on it in class. Feel free to talk about, go to the proofs and talk those through together. I know it helps when we talk them through out loud together. So go ahead and do that as a class. You can do that quietly with each other, but don't just sit and chat.